Inventions That Changed the World by David Mall. Penguin Readers, Level 4. Text copyright David Mall 2005.
Chapter 2. Mathematics. Without mathematics, it may be possible to build a very simple house, road, or bridge, but greater understanding is needed for more complicated jobs. People realized this at a very early stage of human history, and their simple knowledge of numbers grew into the skills which allow us to build computers and use the internet. Pythagoras. In 525 BC, the king of Persia led his army into Egypt and took many prisoners. One of them was a Greek mathematician, Pythagoras. Pythagoras was sent to Babylon in modern-day Iraq, and there he had the opportunity to study two things which the Babylonians really knew about: mathematics and music. It is possible that he learned about right-angled triangles from the Babylonians. Some Babylonian writing, from at least 1,000 years before his visit, says, 4 is the height, and 5 is the longest side. How wide is it? Its size is not known. 4 times 4 is 16. 5 times 5 is 25. 16 from 25 leaves 9. 9 is 3 times 3, so 3 is the width. But they never formally proved this. In mathematics, the most common system of counting uses the number 10. We count up to 9, then we use the 1 again and start changing the second number, 10, 11, 12. From the Sumerians, who had lived in the area before 3500 BC, the Babylonians had taken a system which used 60. They didn't have to learn 60 different signs. Each of their numbers was built up from just 2, 1 for 10 and 1 for 1. So when you reached 59, you had to write 5 10 signs and 9 1 signs in a special arrangement, but the Babylonians didn't seem worried by this. The system was good enough to tell them about amounts of building materials, the number of workers necessary for a job, and how many days were needed to complete it. After around 5 years, Pythagoras left Babylon and returned to his home on the Greek island of Samos. There he started a school of mathematics. But the Samians had a problem with his teaching methods, and they also wanted him to take part in local politics, so after 2 years he moved to Crotona on the southern coast of Italy. He started another school there, which took both male and female students. Some of them lived in the school all the time. They owned nothing and ate only vegetables. They were taught by Pythagoras himself and believed in certain ideas. One of these was that, at its deepest level, nature follows mathematical rules. The teachings of Pythagoras came from this school. He wrote nothing himself because the school was very secretive. Modern mathematics is interested in making up and solving mathematical problems. Pythagoras' school was interested in how mathematics worked and what it meant to prove something. This was a great step forward from the Babylonians, and the new mathematicians thought of right-angled triangles as 3 connected squares. Together, the areas of the squares on each of the shorter sides are the same as the area of the square on the longer side. This could easily be proved by cutting up the 2 squares and putting them together to make the third. The Pythagoreans were making good progress toward a mathematical description of the world when they were stopped by a simple problem. If you have a right-angled triangle with 2 sides, each of a length of 1, then 1 squared plus 1 squared equals 2, so the length of the third side is square root 2. But this can't be given as a whole number. You can start with square root 2, equaling 1.414213562370950488016887242097, and you can continue forever. So you can only write this number as square root 2. The Pythagoreans then discovered that square root 3, square root 5, square root 6, square root 7, and square root 8 are also not whole numbers. So, some of the relationships in nature couldn't be written down using numbers. This was a great problem for their way of thinking. Euclid. Around 200 years after Pythagoras, a man called Euclid lived in Alexandria, Egypt. Although his home was there, he was Greek. He certainly traveled to Greece, and it is probable that he spent some time studying with Plato in Athens. When he returned to Alexandria, he started a school of mathematics and wrote a great book on the subject, The Elements. This was still in use in some schools in the 20th century, and it has been said that after the Bible, it has been more studied, translated, and reprinted than any other book. Many of the ideas in The Elements didn't start with Euclid. He wanted to bring all knowledge of mathematics together in a single book. He also introduced a new way of thinking, by proving an idea, then using this to help prove another one. This sounds simple enough to us today, but it was the beginning of the method of proving ideas that we still use. The Romans. After the Babylonians, the Egyptians, and the Greeks, the Romans ruled the Western world. They understood mathematics well enough, but they weren't very interested in it. Imagine a Roman engineer who has to build a wooden bridge across a small river. The Romans took their measurements from parts of the body, the length of a finger, a hand, a foot, and, for longer distances, a double step. The bridge will be 44 double steps long and 4 double steps wide. The pieces of wood to make the road are each 2 double steps long and 1 foot wide. There are 5 feet to each double step. So, to reduce everything to Roman feet, you simply write bracket 44 times 5, close bracket, times bracket 4 times 5, close bracket, divided by bracket 2 times 5, close bracket. Unfortunately, you have to use Roman numbers, so it will actually look like this. Bracket XLIV times V, close bracket, times bracket IV times V, close bracket, divided by bracket II times V, close bracket. Of course, Romans didn't do it this way. Numbers were only used for writing down the answer. Instead, they used a simple machine or a counting board, and within a few seconds, got the answer of CDXL, 440. Roman engineers were highly skilled. They built roads, water systems, bathhouses, and great buildings. But for them, as for the Babylonians, mathematics was a way of improving their buildings, not improving their minds. Pure mathematics, which began in Greece, wasn't reborn in Rome, but in the Middle East. Al-Khwarizmi. For counting, we use 9 numbers. Each of these numbers can have a different value according to its position. So the 1 in 100 isn't the same as the 1 in 10. This idea began in India around the year 500, and from there it moved to the Arab world. Around 786, a man called Al-Khwarizmi was born in Uzbekistan. Later he worked in a school in Baghdad, and there he wrote a book about using Indian numbers. When this book was translated into Latin, it introduced the idea into Europe. Al-Khwarizmi is also known as the father of algebra. In fact, the word algebra comes from Al-Jabr, part of the Arabic title of another book by Al-Khwarizmi. In this book, he describes 2 important ideas about equations. First, you can move things from one side to the other, which makes equations easier to solve. For example, 4x squared equals 12x minus 2x squared becomes 6x squared equals 12x so x equals 2. He also showed that you can make an equation easier by taking away the same amount from each side. For example, x squared plus 4x plus 40 equals 11x plus 30 can be reduced to x squared plus 10 equals 7x. So x equals 5. Although Romans did little to add to our understanding of these new ideas, the ideas became more widely known when they were written in the Roman language, Latin. When the works of Pythagoras, Euclid, and Al-Khwarizmi appeared in Europe in Latin translation, they helped to move human progress forward.